Our competition is tomorrow. Let's review our code so that the few people that will be working and doing rapid response debugging are familiar with some of the quirks and the latest trends. These first 2 minutes, I'm going to give a very quick overview of just how our structure works. Feel free to skip the first 2 minutes if you already know. So we have a core robot.java file inside of our Eclipse workspace. So our Eclipse workspace holds on to our dependencies. It allows us to reference all of these imports that we use. WPI from the Worcester Polytechnic Institute and Strongback from team in uh, Missouri is awesome. So these are the things that we will often import from our workspace, uh, but all of them are in the same folder, or aka package, that we can link to and reference here. We have a robot.java file, and the robot.java file connects a bunch of these imports, declares a lot of variables, instantiates things in memory, as well as creating little smaller primitive variables that'll hold like where we're positioning one thing or another, what our current gyroscope value is. Just other reference numbers to write down. And then we have a lot of functions, three basically that are built in with us. We have our own other classes as well. Our own wrapper, as well as different command objects copied from Strongback and then told to do specific things, and then groups of them that do series of commands in a row. Okay, so minor complaint to start the conversation. At right here, we have in robot.java, we have some static variables that make sense because these are constants and they can be static. Is carrying is being written down as static. That doesn't make sense to me. It would make sense that that is uh, a instance variable because it's not this variable doesn't talk about robots generally. It talks about our specific instance of a robot. So that's the opposite of static. Um, so current state of that robot, to me, just conceptually shouldn't be static. It'll work fine in our instance because our code only deals with one robot. So static or not, it all refers to the same robot. Um, just in principle, I'm being a snob. My first concern that I want to note is button 9 and 10 versus button 5 and 6. So, and button 2, yeah, button 2. 2, 5, and 6 versus 9 and 10. So what 9 and 10 does, this was our original design, is that you press 9 and the lift elevator goes up. So when this is triggered, it passes this command. Technically, as Sebastian will tell you, it passes an anonymous command that inherits the runnable interface, which then runs this as the anonymous class's past method. But don't worry about it. So when you press it, the elevator starts going up. When it gets untriggered, the elevator stops. You press the other button, it goes down. When you let go of that button, it stops. Very, very sensible. But in competition, we don't want to be sloppy. So we want precision. Let's go high position for the high goal, the teeter-totter that's 7 feet up versus the switch that's a little bit lower versus the ground, where we pick up the box, the cube, the power cube. So we have Sebastian has rigged a new command called arm return that sees where the current state of the robot is, and based on that will lower the robot into correct position. So it doesn't actually need any of these like extra variables that are being passed. He just hasn't cut them out of the constructor yet. So this can be cleaned up because all it does is it queries where the current state is, and it will lower the arm based on how much time it needs. So we'll need to manually adjust that. We'll need to test that to see, oh, it's overextending or it's not lowering it enough from the mid or high position. So we need to figure out, we need to fine tune it so that that arm return, no matter what the position is, um, will be accurate. Now the problem is if you lower it a little bit manually and it still thinks it's high, at its highest position, but you've already manually lowered it using the button 10. If you hit arm return while it thinks it's in the high position, it's going to possibly rip the motors off the pulley and just dramatically overextend. Um, and possibly do damage to the robot because it's going to turn for longer than it needs to because it thinks it's in a high position and in fact you lowered it already. So we might need to disable these buttons, or if these buttons work and if you use them a little bit, then it'll automatically adjust the current state. So we'll need to somehow balance that out. Um, I want to point out the difference between arm return and arm command, and we also have pneumatic grab. Um, so some of our pneumatic grab, pneumatic release. So some of these classes, we have duplicate classes that can be consolidated. The pneumatic grab, if you call a pneumatic grab command or pneumatic, you should be able to just pass it a variable about what you want it to do. We don't need to have a separate class for each specific function. We can have like a more flexible arm command that you pass it what you want it to do and that one file can handle any sort of ARM related command. So we can consolidate some of this code as well. And so another one of our issues is that we're starting to have um, duplicate files. And so that means more points of code that we'll need to maintain. So if we change how we do things, we need to make sure that the rest of the files are in line, or we need to consolidate as we move, which can also be tricky. Another one of my concerns is about the autonomous mode selector. So we would select one of these scripts, left drop, right drop, middle cube, and which one. So we basically have left, right, middle drop. And so if we look at left, right, middle drop, we'll now see that this, in order to figure out, so we're on the left side and we want to drop off the yellow milk crate on our given side of the local teeter-totter. And now that we need to figure out which side is ours. We won't know until we won't be able to tell the robot. The robot will need to figure out on its own. And so it can query a game-specific message. And uh, we'll tell it to see whether or not we have it has a robot. Sorry, whether or not we have on the left side. Um, I don't know why we're testing to see if its length is greater than 0. And then we're doing that versus this. We should be char at 0 is if it's equal to r. And we're testing the literal, so that's okay. You can do equals equals because a char is a literal. But you can, I don't understand why if its length is greater than 0, do it, drive to the other side, and shouldn't it just be is equal to r? Anyway, but why have this duplicated code in each one of these, right drop? You have the same code over here. So why aren't we making the determination right here, getting the game data here, and calling the appropriate script? I mean, I guess, well, or why aren't all of these three methods calling the same method, same function. We could pass it a function. We could do any number, have a separate class that just runs this one code. So if we do find a bug in how this works, we have three different places to change it. This should be consolidated so that we see, okay, what's the where how did they get randomized? We see that we check that string in one place, and then it calls the appropriate sequential command to drive to the right place. And ironing out these scripts, each of the 9, is going to be a very tedious job because we have to test each one and then fine tune the motion so that it's reliable in autonomous mode. That means a lot of practice time, and we're going to be wrestling with the build team to try to get time with the robot to get these to see if they're working accurately. So we'll need to test them, and the neater the code is in advance, the better a time we're going to have. So consolidation here could be a big help. So look for that change. We also don't have, so the solenoid and what the buttons do with pneumatic controls right now is uh, commented out to help us testing. We're going to need to bring these back in, and they might also be switching the solenoids position, so forward and reverse might do different things. So we're going to need to comment these buttons um, to sort of test and to see how the new pneumatic controls are working. We're going to have to bring these back into play and then test and add in some notes about which one does which. So that'll be some work for tomorrow. And we'll also need a button to raise and lower the winch. That we can just take from previous year's code, the IO's code, and that'll have the uh, buttons just to activate and lower the winch motor that we'll have created up here in a similar sort of fashion. And so that should take care of that. The rest of the issue will just be about fine-tuning speeds. So if you're trying to adjust one controller or another, are we using the right speed? Um, finding out the different commands, what we can do to iron things out, and of course, testing and fine-tuning all of the autonomous mode scripts while we organize and better structure and comment our code. All during the competition. It's going to be crazy. It's going to be crazy.